So the next question is, again, what is the total charge of a, and we're gonna talk today about balloons shell. So balloons shell. So what is a balloon shell? So let's draw a balloon. Balloon is a kind of have a spherical shape. You see, this is a balloon. So maybe have this thing here. And let's do a coordinate system, which is z, x, y, right? So perfect. What we need to find? We need to find what is the total charge. And the total charge is actually bidding for a small blocks, as we did before. This is a 3D figure, right? So we need a small blocks that gonna sum up to be this thing. So how are we gonna do it? So they're telling us, this is a given star, telling us what is the charge density on this thing. So we said the charge density on the shell, let's give it some depth. Here it is. The shell of the balloon is sigma theta, this time theta, not r, equal to 2 sigma naught over pi square multiplied by sinus theta. Okay? By sinus theta. And what is theta? Theta is the angle. They give us the angle from here. This is theta. Okay? That's what it means. Okay? So what we know about sinus theta, just to think about how the charge is distributed on this shell. So we know that sinus is actually the one that starts with nothing and becoming the best, right? At pi over 2. And then remember, who is it? Where it started, 0 pi. So if I'm gonna look at this angle, so this one, at the beginning you have nothing, there's no charge in the top part of the sphere, on this pole, right? And when you go to the floor, you actually have most of the charge, right? And then when you go here, again, it vanishes. Okay, so this is the idea how it looks like. It's not that important, but it's good to just to know it inside your mind when you see sinus, what's going on in the problem. It's going to be relevant in the next classes. So what I want to do, I want to divide it to small chunks. I want to find what is dq. dq is equal to sigma multiplied by dv, some piece of volume. So how you gonna divide spherical coordinate? This is a sphere. So we're gonna use, as I told you before, theta and this theta, and we also have the previous one we used, which right now got a different name, which is phi. So if I have here a small chunk on it's like a, let's put it here, it's like something that somebody stick into the, let's do it that way. This is theta, right? Here it is, and we have also phi. Here it is. Phi is actually the angle that's going from here, to the shadow of this part. This is phi. Okay, so I look at that like a sniper shooter. I imagine somebody with the sniper gun, you know, and he have the gun, and then he decide how much theta to go to him, and then if you want to turn around, you use the phi. So that's the idea. You have this theta, which is going down, and you have this phi, which says where to go down. Okay, it's really important. And so how we can depict what is the size of this thing? So look at this. So we know that a small movement in theta, let's get rid of this because it's losing the idea of the three-dimensional thing. So this is like, you know, a puzzle thing, like a sticker on top of it. So this movement is the radius of the sphere, which is r. So this is r d theta, perfect. But I want you to be careful, because this part is not r phi, it's actually r sinus theta d phi. Why so? Because if you can gonna see, you see that this one have a shadow, some shadow over here, right? This is the shadow, and the movement, and the movement of this part is from here to here have another radius. It's the radius of the shadow of R, the big radius. You can look here that this one and this one, let's clear this one and this one are the same, right? So this is, I can find it by sinus theta. It's the reason it's R sinus theta d phi. You can look on Wikipedia and see why this is d sinus theta, or maybe look in a atlas and globe and see and have some idea why it's so. But what I want you to say, first of all, it's not a volume, it's a surface, because we're talking about only the shell of the sphere. Sorry about that. So what is this value? Is r d theta, right? Multiplied by r sinus theta. And look at it, I did a big R because it's not any R that I want. We're going only on the shell of the balloons. We don't care about what's inside, about the air, the atoms inside. I don't care about them. I care about only the things around the shell. So this is the reason it's a sigma and not a rho. So R sinus theta d phi. So what I have here, R square is sinus theta d theta. So this is this part, and what is the sigma? I already know it. It's 2 sigma 0 pi square sinus theta multiply. So you see that I have two sinus. So let's do 2 sigma 0 r square over pi square, and here I have sinus theta square d theta d phi. Perfect. So this is my dq, right? And what I want to do with this dq, I want to sum them up in order to find what is the total charge of this balloon. So let's take another color. Let's do this. So I don't need also the charge density. I already used that. So Q total is equal to what? To this thing. So integral of, I already see that I have two integrals, right? Of this, which is the constant, which is going to go out with my fishing rod, over pi square, sinus theta square, d theta, d phi. So if I'm going to use d theta, what is the angle that I have? From 0 to pi. That is the limit. You know, when I have this going all the way down, this is pi. I don't need these angles, right, more than pi, because I can just turn around. It's easier to turn around and then go down. We don't want to count stuff more than once. So this is from 0 to pi, and if we how much I can turn around, so 60 degrees, which is 2 pi in radius. So this is the idea. Let's take the constant out, which is 2 sigma 0 r square over pi square integral 0 to pi sinus theta square d theta, right? And now we need to solve this integral, which is a little bit challenging. It's a little bit challenging integral, but we can overcome it. First of all, we can change the sinus to cosinus, right? By doing what makes it complicated. We know how to do the integral of sinus or cosinus or whatever, but we have this square. So this square makes things a little bit complicated. So we want to get rid of the square, maybe have something different in the angle, or sinus or cosinus, but we want to get rid of the square. So how are we going to do it? So we're going to do it with two equations. The first one is I'm going to change it to cosinus square theta. I know that sinus plus cosinus square equal to 1, so I'm going to use cosinus. And for cosinus, I remember another equation, which is that cosinus square theta equal to 1 plus cosinus 2 theta over 2. So using this one, from now on it's only a math thing. So I'm going to eventually do this, and I have integral. I'm going to call all these constants just c. Okay, and then I'm going to put them in the end. So what I have here 1 minus that. So I'm going to have here integral of 0 to pi. I didn't change any variables. So 1 minus half, it's half minus cosinus 2 theta, right? theta. And let's continue. So this one, what is the integral of this one? You just multiply it by theta. Right? Okay, wait, this also should be over 2, right? And this one actually can go with the 2 that I have outside, you see? So I can already cut, now you can put a C. We can cut this with these 2. And then we have here pi, right? We have sigma 0 r square pi square integral here. Wait, sorry. I'm gonna apply the integral, okay? So it's gonna be theta minus sinus, right? Sinus 2 theta over 2 from 0 to pi. And we know that sinus get the same value for from 0 and for 2 pi, right? So if we're going to apply 0 minus this one, so this is going to cancel out, and I'm going to left out only with pi. So this is actually all this thing equal to just pi, and this pi can go along with this pi. So we have actually here sigma 0 r square over pi. That is the solution. Let's check it to be sure that we are okay. And I have here yeah, I think this is I don't see what I did wrong. I have another solution in my notes, but this should be okay. I did everything right. Yes. So if you see any mistakes, so let me know in the comments, but for me it's look okay. Okay, so this was this question, and right now we're gonna do another sphere question.